Dear students, this is Dr. K. Sarunan, Associate Professor, Department of Information Technology, R&D Engineering College. My dear students, now we are going to discuss architecture of 8086 microprocessor in detail. Intel launched 8086 in 1978. The 8086 is a 16-bit microprocessor with 16-bit data bus, that is D0 to D50, and 20-bit address bus A0 to A19, can access up to 2 to the power of 20, that is equal to 1 MB memory locations. It has multiplex addresses and data bus AD0 to AD50 and A16 to A19. It can support up to 64K I/O ports. This 8086 provides 14 16-bit registers, and 8086 requires one phase clock cycle at 33-degree duty cycles to provide optimized internal timing. The range of clocks are 5 MHz, 8 MHz and 10 MHz. 5 MHz for 8086 and 8 MHz for 8086 version 2 and 10 MHz for 8086 version 1. 8086 employs parallel processing. 8086 CPU has two parts which operates at the same time: bus interface unit, execution unit. Coming to the CPU function, the fetch operations can be performed by the bus interface unit, and decode and execution process can be performed by the execution unit. Bus interface unit sends out addresses from for memory locations and fetches instructions from memory, writes data to memory, and send out addresses for I/O ports, reads and write data to input/output ports. Coming to the execution unit, it tells bus interface unit addresses where to fetch the instructions or data, the decodes and executes instructions. Dividing the work between the bus interface unit and the execution unit speed up processing. Let me see the architecture diagram of 8086. So this is the architecture diagram of 8086. See, this bus interface unit it is clear from the diagram that only the bus interface unit direct links with the memory, and this memory can be directly accessed either by the segment register, the instruction queue pointer, or the instruction queue for fetching of the instructions. Coming to the bus interface unit, the instruction queue contains a set of instructions which is to be executed to make the processing faster. The 8086 fetches up to 6 instructions in advance and stores them in the instruction queue. So, whenever one instruction completes its execution, the control unit need not to wait for the next instructions to be fetched and then brought for executions, because job is already done and the next instruction that is to be executed is ready in the instruction queue. Coming to the segment registers, there are 4 segment registers in 8086. Each segment registers can work up to 16 bits of binary data. There are 4 types of segment registers, namely CS, DS, SS, ES. CS is a core segment register, and DS is the data segment register, and SS is the stack segment register, and ES is the extra segment register. Coming to the instruction pointer. The instruction pointer contains the address of the next instructions that is to be executed. Now we will discuss about the EU. EU is the execution unit. All the instructions are executed inside the control unit. It is main component which is responsible for processing of any processor. The execution unit consists of main components like instruction decoder, control system, arithmetic logical unit, general purpose register, flag register, pointer and index register. And this instruction decoder translates instruction fetched from memory into a series of actions which EU carries out. Coming to the control unit, that generates timing and control signals to perform the internal operations of the microprocessor. This arithmetic and logical unit, all the mathematical and logical operations performed inside the ALU. So if any instructions need to perform such operations, the control unit handovers it to the ALU. That means the execution unit has 16-bit ALU which can add, subtract or decrement or increment or shift binary numbers. Coming back to this architecture. The flag registers in 8086 is a 16-bit length which consists of 9 flags and the rest 7 bits are don't care cases. General purpose register. The general purpose registers of 8086, there are 4 general purpose registers. They are used as containers for storing the value which may be required for executing the instructions. Each purpose register consists of 16 bits. There are 4 types of general purpose registers, namely AX, BX, CX and DX. This AX, BX, CX, DX registers are 16-bit register. It is a combination of AH and BL, and the combination of BH and BL is a BX register. The combination of CH and CL register is the CX register, and the combination of DH and BL register is the DX register. The AX register is acted as an accumulator. Pointers and index registers. Coming to the pointers and index register, the 8086 consists of following pointers and index register. Here, IP is not mentioned because it is not a part of bus interface unit. So the 4 pointers are BP, SP, SI, DI. BP stands for base pointer, and SP stands for stack pointer, and SI stands for source index, and DI stands for index destination index. So operands, these may be used within the instructions. And thank you so much students for listening my speech. Thank you.